Over the years, I've noticed a lot of networks have problems, especially when there's a large number of users. And we experienced this when I was working on site at Open Source Ecology. We have the same problem now at Starseed Gardens, where we're setting up open civilization, and um, these are the steps that we're starting to figure out how to solve it. So we picked a particular router called a MikroTik, which is a really cheap router. It runs some variant of Linux on it. I don't know if, I'm sure you can probably hack it to put your own installation of Linux on it, but at the moment we're trying to solve it based on their router runners. So we're going to set up queuing that queuing and limits on uploads so that our upload is never more than 90% of our actual upload speed. That allows us to be able to manage a queue, and that queue can then prioritize some data ahead of others, so that when you're doing things like uploading to YouTube or uploading videos, that it doesn't kill the user experience for everybody. So I'm just going to get Michael to describe some of the things that we need to prioritize ahead of others. So what are they?
Well, the first thing that we need to do is get control of the queue. Because the way that internet devices work at the moment is we've got a router here and it's got a queue on it. Could be a few hundred packets. Then it talks to the microwave dish, and that's got a queue on it of a couple hundred packets. And then that sends up to the internet service provider, which has a queue of a few hundred packets. And what happens is when you're uploading a video, all these queues get stuffed full of data packets. And then if somebody else wants to view a web page, then their request to get the web page has to wait for that whole queue to clear out before the request can even get through, which provides an extremely unpleasant user experience.
And so what are the protocols that we want to prioritize ahead of others?
Well, first off, what we need to do is take control of the queue so that we control the queue, which means that we have to limit the upload to slightly less than what we can actually get, which means that all the queues upstream of us will be empty. As soon as the packet comes in, it goes straight out again. So that when we control the queue, we can put those requests, those web page requests, ahead of the YouTube data, for example. To do that, we're going to set this thing up here with the hierarchical token bucket tree, which is a fantastic piece of network engineering that basically allows us to allocate certain amounts of bandwidth for various activities. But if one activity isn't happening, then other things can use that bandwidth. So for example, when everyone's asleep, you can upload to YouTube at full speed. But when other people start using the internet, then it'll automatically cut down your YouTube upload so that their experience is still rapid.